Hello everyone, it's September the 1st. Wow, we are into September now. Alright, let's take a look what we have. Array nesting. Come on, it's so slow, the internet. You're given an integer array of length n where nums is a permutation of the numbers from 0 to n minus 1. You should build a set sk nums k nums k. Hold on, nums k is a value. It's value from 0 to n minus 1. Subject to the following rule. The first element sk starts with the selection of the element num k of index k. The second element should be, and then so on. We stop adding right before a duplicate number element occurs in sk. Return the longest length of. How did you guys think about all this type of stuff? Who came up with this? Alright, so but we can pick any k, right? It's just a set. Nums 0 equals 5, nums 1, nums 2, One of the longest sets is S0. We call it the k, just the starting number. So nums 0 will be 5, so next one nums 5. Nums 5 is 6, so next time is nums 6, which is 2, which gives nums 2, which is 0. And then we have repeats. Wait, what is a repeat? We stop adding right before duplicate elements occurs. Oh, because it's a 0, then we go num 0 again. Huh. I have no clue. Hold on. Okay, 0, 1, 2. Nums 0 is 0, nums 1 is 1, nums 2 is 2. So sk can be S0, S1, and S2. If we go S0, then the first value is num0, which is 0. And the second value is the previous value, 0. And it's 0. And then we repeat. And we end. So it's 1. Nums 1, so it stays in the... Okay. I see. And what we want is the longest. So how many times we can just jump around, right? So how many times we can jump around? Yeah, like if it was 0, will be 5, so we jump to 5, right? 0, 1, 2, 3, 4, 5. And from 5, we jump to, because it's 6, so we jump to 6. And then we jump to 2. And we can try, right? We know starting from each, that's unique, right? The number of jumps that it can do starting from each value is unique. Therefore, if I say I'm going to start with num 0 equals 5, right? And then we can jump, and then we start from nums equals whatever, and then we jump, right? And then we can record the total numbers that each one can have, right? And then we just keep going to the next one, and next one. So the total runtime of doing that, I mean, each value will be visited once. So if we cache it, it shall be on, which I think shall work, right? So each value, we simply just, we cache it. And then each number will visit only once. But how do we know when to stop jumping from a certain value? The stop condition is different, right? If I start from 5, right, and then we jump here, we jump here, we jump here, and then we need to jump back. That's when we say, okay, we need to stop. But if we start from, let's say, here, right? If this is the starting point, S6, right? No, S5, S5. So if it's 5, my first one will be 6, right? And then we say we jump here, and I'll jump here, right? Now we don't stop. We'll keep jumping, right? We'll keep jumping. This one will keep jumping. So like the subproblem is restricted by the parent problem, because the parent starts from 0, right? So the next jump cannot be 0. It cannot be 0. But if I start from 6 with no restriction, and then we have another thing, then we have a restriction. It's like if the restriction is here, then we start from here. What's the longest? Then it's a completely different problem. No, graph. Let's try graph. We have basically 5, right? So let me just write it out. 5, 4, 0, 3, 1, 6, and 2, right? And each one has a position. All right, so 5 can go to 5, right? 5 can go to actually 6, right? And the 6 can go to 2, and 2 can go to 0, and 0 go back to 5. So that is a loop. And once you know the loop, right? Once you know the loop, then nobody else can be inside this loop. And no matter where else you enter, because that's a loop. So once you get the loop, and then go to the next one, we'll start from 4, right? 4, we can go to 4, go to 1, and then 1, go to 4. That's it. And then next one is 2, or 0, right? It's 0. So if we go 0, we will go to 5, and then go to 6. So it's the same. Once you find the loop, any value you encounter will be inside the loop. So all we need to do is to find all these loops, right? So just find, we group them together so they become the same group. You're gonna say union find? No, we don't need to use union find. What we need to do is just find the loop from the starting point, right? We find the loop, and then we're gonna create another list, right? Another list where each value will become a group, right? So like 5, we say this is group 0, right? And now we go to 6, 6 becomes group 0. Yeah, 6 become group 0, and then 2 become group 0, and then 0 become group 0. They all become group 0. And then once we're done, we also get the size. And the next one, if it belongs to group 0, then say, oh, no, we already found it. So we just keep going to the next one. Because every value that has been found to be inside a group, inside this chain, will always be in this chain. It cannot be reached by other values. That is correct, because every value is unique. So that is our solution. It's still ON, but it's different. So okay, we have to make a new folder. So we're gonna do this, right? And then we're gonna copy. This is gonna be 9. This is also 9. Oh my god. Spelled wrong. 21. There we go. There we go. So 0, 1, 9. Okay. Alright. So this is the inside. The key inside is if we find a loop, we find a group, then this group will not change. Right? So any future value we encounter can just be, yeah, so groups, sets, right? Sets equals, same thing, let's say -1 times len nums, right? Then what do we do? Then what do? We just go for, right, for n in nums, right? And then we're gonna go loops. We say if sets n is larger or equal to 0. Let's just go 0. So we can just say if sets n, continue, and we'll just say if not sets n, right? That's when we start with the loop. And we also need to have res equals, this is the size, 0, right? If it's not, then we say temp equals 1. That's how we start. And then what we're going to do is while doesn't matter, while nums, I need to do a new one, so we're going to say n and let's say index, right? Index this equals n and 1. And while nums index, right, nums index is the one we're next going to check. So, and then we say sets num index while not, right? While not sets index, and we have to search sets n equals, equals what? Doesn't matter, we can just equal 1. It doesn't really matter. We don't have to identify which ones. All we need to do is, I mean, it's possible to identify, but we don't have to. So while not sets, right, which means it has not been inside a set, we do sets nums index equals 1, right? And then what? And then when the update index, so index equals nums index, right? And then temp plus equal 1. We have a new one. And then we have a new index, so come back. If this one is, and then we get out, and then res equals max res temp, right? And go through all this, finally return res. Okay, so let's see. We only have 2 test cases: 5, 4, 0, 3, 1, 6, 2. This one shall return 4. Next one is 0, 1, 2. That shall return 1. Okay. So here is nums, and this is array nesting nums. All right, try it. Both paths. I have confidence. Let's just try it. 1. Let's try 1 value. No, it should be the same. 1 value. Yeah, I don't see any difference between 1 value, right? It's the same. Oh, yeah, this has to be 0. It'll just be 1. Yeah, I think this is correct. All right, let's go for it. Pending, judging, accepted. Yeah, this is correct. Okay, so the key insight is that once a set is found, it is static. It does not change. Right? It does not change. This means no other number can enter this set. Therefore, we can easily find all such sets in nums without having to repeatedly check every number, because once a number has been checked, it is good. Has been checked, we don't have to check it again. As we go through nums and figure out each set, we also keep track of the size of the set. And eventually, we can return track of the max, right? The max size of the set. Eventually, we can return the max size. On, time complexity, because each value is visited at most twice. It's not actually, each is visited at most twice, yeah. And O also on space due to the auxiliary array sets. And the runtime is 143 milliseconds, or 29% ranking. So we have faster, right? What do we do? Faster. Oh my. What is this? Oh, I see. Huh. Very good. You don't have to set up a new one. We just take it to -1. While v is not. M. I v nums v. Nums I. And this is the official solution, right? Yeah, it's the same, but you don't have to create a new set. I see. Yep, it makes sense. Makes perfect sense. Yeah, I'm gonna try that. 565. So this is 565. Brute force using visited array. This is the same as mine. Do while. Who used do while? most once. Yep. All right, nothing special. So I think just gonna use that smart solution we just saw. All right. Same idea as solution 1, but O1 extra space. All right. So what do? We're gonna say for I n in enumerate nums, right? So nums I equals -1. Yes, we use -1. And then, we need to have res equal to 0. And then temp equals 1, right? And then we say what? Now, I don't like to change, so I'm going to say same thing, index. Right? Index this equals n and this. Okay, while nums index is not equal to -1, temp equals equal 1, right? So we go to the index, and then index shall equal to nums index. All right. Hold on. So n is the value of the next index. So check. So the next index will be this is the next index. This is the next index, right? Get the next index, and nums index shall equal to -1. I think this is where we can make the change. We can say index nums index equals this and -1. And then we go to the next one, until we jump out. Res equals max, res and 10. And then for anyone we visit, right, and we have the index is n. If it's already visited, yeah, we can do this, it's fine. And then we return res. All right, try this. Nope, something is not right. Hold on, so I have, as I, we set it to -1, and then n is the index, temp is 1. So nums index, so we go to here, and not -1. Okay, we add this, and then index what equals nums index. Our index already changed. You know what? I think just don't do it this way. And nums. Oh, hold on. We do need to do it this way, but index. Wait, but this one is not right. Index equals nums index, and nums index equals -1. Yeah, because you do this, index changed, so this one changed. Let's not call it temp. Let's call it size. All right. This will be size. So what we need index. So we need temp equals nums index, right? And then index equals temp equals this, nums index equals -1, and then index equals temp. Yeah. How do we change this? Is it like intermediate value, right? I don't know. I don't think it's possible. It's AB equals BA. It's A equals B. Let me try it again. What if we do nums index, right? Index equals -1 and nums index. I think this one pass. Huh. What's the other one I wrote? I wrote index nums index equals nums index and -1. So it does do this and this first, right? It does a set up an intermediate value for this. And now we assign this, and then we assign this intermediate value. In here, I set an intermediate value for this. Okay, this equals this. So this is already changed. So this one cannot be changed. So we do set intermediate value for the start. So we need to make sure these two are the same. Gotcha. So this is how we can make it simpler. Like this. Right? Okay, let's try this one. Actually, I want to write a comment. Make sure in A, B equals, make sure this syntax, right? This syntax requires that requires that AB equals CA. Requires AB equals CA. This is to say, and this is to say, the left value variable must be the same as the right variable, because Python creates an intermediate value for the left. Just to remind myself. I think with this, it'll be very clear. Alright, let's submit this. I think it'll be faster. What? We got it wrong. So the answer is 2, but we got 3. Interesting. Why? Again, if it goes to 0, right, then itself turns to -1, value is 0, and then, so that's 0. Now I go to 2, right? And 2, this is my -1. And then value is, index is 2. So we'll go here. And this is, so in size becomes 2. And num's index will be -1. This will be -1. And index will be 1. Right? Coming back, this -1 comes out. So the rest will be 2. And then to this one. This one, its index is already, so we skip on to this one, 4. 4, okay, -1. How do we get to 3? All right, let's try. So just print index. All right, for index and size. Index is -1. So 2 is 1. And then wait, hold on. How does index become -1? No, you gotta be kidding me, right? Shoot. Num's index is -1. And index equals 10. Telling me that nope, that's not issue. This is correct. How the index become -1? Oh, I see. Because I comment to this one, and this one's -1. Ah, yeah. Okay. So to avoid this, maybe we can do this. Let's say size equals 0, right? And index size equals I and 0. And we say if this is not, we do this, and we do this. Yeah, I think it actually make it even better. Yep, I think this will even make it better. Alright, let's try this one more time. Yep, this one passed. Okay, it's much faster. So we hit 108 milliseconds or a 92. Alright, that's it. That's it for today. See you guys tomorrow. Adios.